Good morning. In my first video, we have discussed regarding different wave propagations. Right now, we are going to discuss ground wave propagation. Okay, what is meant by ground wave propagation? So, ground wave propagation, we have already told whose frequency less than 2 megahertz means any frequency signal less than 2 megahertz signal I can transmit using ground wave propagation. I can transmit using ground wave propagation. Okay, so how the wave will be propagated in the ground wave propagation? For example, let us consider this is the earth surface. This is our earth surface. This is our earth surface. Let us consider this is your transmitting antenna and this is your receiving antenna. So in the ground wave propagation, the wave propagates along the curvature of the earth surface. The wave propagates along the curvature of the earth surface. So those frequencies less than 2 megahertz signal, those frequencies less than 2 megahertz signal means the short waves, okay, medium waves we can transmit using ground wave propagation. Means those frequencies, if I want to transmit any information from the sender to receiver, from transmitting antenna to receiver whose frequency is less than 2 megahertz, then I will go by ground wave propagation. Then I will go by ground wave propagation. In ground wave propagation, the wave travels along the curvature of the earth surface. The wave travels along the curvature of the earth surface. Why this wave only travels very nearer to the surface? Why by using this ground wave propagation? Why I cannot transmit more than 2 megahertz? Because the main reason is as you are increasing the frequency, as I increase the frequency and if I am transmitting very nearer to the earth surface, earth absorbs the signals. So what happens if I transmit the high frequency signal? So let us consider this is your earth surface, this is your earth surface, this is your transmitting antenna, this is your receiving antenna. If I transmit high frequency signals very nearer to the earth surface, before it reaches the receiver, the earth absorbs high frequency signal and the wave will get die off before going to the receiver. So this is one important parameter why you are not transmitting high frequency signal using ground wave propagation. You are transmitting the ground wave propagation very nearer to the earth surface, very nearer to the earth surface. So another problem of ground wave propagation is that diffraction and tilting. Another problem of the ground wave propagation is diffraction and tilting. For example, let us see here. This is the earth surface. Okay. So this is transmitting antenna. This is transmitting antenna. For example, as the wave is traveling around the curvature of the earth surface, the wave goes on tilting. The wave goes on tilting. For example, like this. Right now, it tilts more. Right now, the wave here tilts more. At one particular instant of time, what happened? The wave, the electrical field component. So this is the electrical field component E tangential. So here at this position, the electrical field component is parallel to the earth surface. The electrical field component is parallel to that. We have seen that the boundary conditions of electrical field component, we have noticed that E tangential component is equal to 0. So this is called tilting. Initially the wave is traveling vertically. As it is traveling from as it traveling along the curvature of the earth surface, the wave goes on tilting. This angle increases. The tilting angle increases. Finally, here the electrical field component becomes parallel to the earth surface. Finally, the electrical field component is parallel to the earth surface. We know from the boundary condition the E tangential component is equal to 0. Hence, before reaching to the receiver, the electrical field component will die. So there are two factors why you are not transmitting high frequency signals using ground wave propagation. The first one is, as they are increasing the frequency, the absorption of high frequency signal by the earth surface will be more. That's why you are not unable to transmit. And by using the ground wave propagation, why are not transmitting long distance? Because long distance, or since why are not transmitting long distance? Because if you want to transmit the long distance, diffraction and tilt takes place. Finally, electrical field component becomes zero. So this is the reason, by using the ground wave propagation, I can transmit a frequency signal less than 2 megahertz. And other thing, the separation distance between transmitting antenna and receiving antenna should be also very less. Transmitting antenna and receiving antenna should be also very less. The electrical field component given by Maxwell's field equation is Et is equal to 120 pi into Hd HR Is 120 pi into Hd into HR into Is by lambda d, by lambda d, where here Hd and HR are effective heights of Hd and HR are effective heights of transmitting and receiving antenna. Is is current induced in the wave, and D is, what is this D? D is distance between transmitting antenna and receiving antenna. Okay. So as distance increases, electrical field also decreases. So this is the field equation given by Maxwell's electrical field equation of ground wave. Maxwell's equation. So finally I can conclude that by using ground wave propagation, I can transmit signals less than 2 megahertz signals. Thank you. We will discuss next ionosphere wave propagation in next video. Thank you.